This is part 2 of the Module 8 lecture. In this section, we're going to introduce the ideas of hypothesis tests in the context of testing a population mean, and this corresponds to section 9.1 in your textbook. All right, hypothesis testing is where we test a claim about the value of a population parameter. In the example that we started with this module, you may recall that the amount of deductible paid by those people that have an employer-provided insurance in 2015 was $1,077, and we wanted to see if that same amount was paid in 2016. So in a way, we're claiming that the mean, because we don't know anything better, of the amount of deductible pay in 2016 is $1,077. So we're proposing a value for the population parameter. And in general, that it happens like that. Someone proposes a value, or someone has an idea, and they give this value or propose this value for the population parameter. Now, if most of the time we want to see if that idea under the null hypothesis is correct or not. So for that purpose, we collect data, a sample from that population, and then the data that we obtain from that sample, we use it to calculate a point estimate. And then we use that point estimate to determine if that is a likely outcome given the assumed value, or the value that is claimed to be the truth. And if that value is not a very likely outcome, then we will say that the claim is rejected. Then on the other hand, if that point estimate appears to be a likely value for the proposed value of the parameter, then we will not reject the claim. All right, let's see how we test the hypothesis. So here's the hypothesis test procedure. We start with a practical problem, and we translate it into what we call a statistical problem. And what you do is, from that practical problem, you elucidate what is the null hypothesis and what is the alternative hypothesis. So H sub naught or H sub 0 is called the null hypothesis, and H sub 1 is called the alternative hypothesis. Also, from this practical problem, we establish the value of alpha. This is the same value that we saw in the 1 minus alpha times 100% that we call the confidence level for the confidence interval estimate. And then once we establish the alternative hypothesis, we use it to identify the direction of the test. Once we've done that, then we move into the statistical analysis phase, where we first select the appropriate probability distribution to use. From that, we determine what test statistic we need to calculate, and we calculate it. And then we use that information to find the p-value, and we find this alpha to find the critical value. And then, either using the p-value or the critical value, we make a decision about the null hypothesis. And that decision is either we reject it or we do not reject it, or as in the parlance of statistical or hypothesis test, we fail to reject it. That's what we call the statistical conclusion. Then, in order to translate the statistical conclusion into a practical conclusion, we interpret that decision, the statistical conclusion. We interpret that. All right, so we're going to learn how to do this through several problems. But first, we need to start introducing some of these concepts so that we can see how this methodology works. All right, the very first concept is that of the hypothesis. So there are two mutually exclusive hypotheses, meaning there is nothing in common between the null hypothesis and the alternative hypothesis. The null hypothesis, or H sub 0, is a claim or statement about the population parameter that is assumed to be true until it is declared false. So in the context of the problem that we started with, the statement of the claim is that the amount of deductible paid in 2016 is $1,077. If we don't do anything, we don't say anything, and that someone proposes that value, well, we'll assume that that is the truth. However, it's likely that someone would like to contest that truth and proposes an alternative hypothesis, which is also a claim about the population parameter that will be true if the null hypothesis is declared false. All right, to clarify this, let's look at a familiar example that I think you're familiar with. And that is, in a legal trial, the general assumption, because that's our right under the Constitution, is that the accused individual is innocent until proven guilty. Therefore, the jury, summoned to make a decision, will start with the assumption that the defendant is not guilty. So that's the null hypothesis. That's the current assumption. If nothing is done, that person is innocent, is not guilty. But then if the jury determines that that individual is guilty, then the null hypothesis is rejected, and then the alternative hypothesis is considered the truth. And you can see that these are two mutually exclusive decisions. Either the defendant is not guilty or the defendant is guilty. All right, I want you to notice here how we write the null and alternative hypothesis. So we write H sub 0 and then use a column to separate that from whatever statement represents the null hypothesis. The same with the alternative hypothesis. We write H sub 1 and then column, and then after that we write the statement that corresponds to the alternative hypothesis. So this is an example that you see the two mutually exclusive hypotheses. All right, another very important concept that is going to be very useful is that of the direction of the test. And as I mentioned earlier, and I mentioned it here, the alternative hypothesis determines the direction of the test. Let's look at the first case. So in this case, the null hypothesis says that the population mean is less than or equal to some proposed value, or it could be written as the mean being equal, or rather the population mean being equal to some proposed value. But the alternative hypothesis claims that the actual mean is bigger than the proposed value. So if you look at this diagram on the right, you see that any value of the mean larger than mu sub 0 will support the alternative hypothesis, because the values on the right of the proposed value support the alternative hypothesis. We call this the right-tailed test or a right-sided test. And one hint to remind you of this, you can see the direction of the inequality sign is pointing to. So this inequality sign is pointing to the right. So that's a right-tailed test. Again, this is just to remind you. Now, an alternative is that the mean is larger or equal to some value. Someone is proposing that. Or that the mean is equal to some particular value. But the alternative hypothesis, that of interest, is that the mean is smaller than the proposed value. In that case, then you see values of the mean to the left of the proposed value support the alternative hypothesis. Because those values are on the left of the proposed value, we call this a left-tailed test. And you see the inequality sign pointing towards the left. The last option is where the null hypothesis claims that the mean is actually equal to some particular value. And the alternative hypothesis claims that that value is not equal, or rather that the actual mean is not equal to that value. So in that case, any value to the left of the proposed value or to the right of the proposed value, they will support the alternative hypothesis. For that reason, this is called a two-tailed test. All right, let's look at some examples of how we establish the null hypothesis and the direction of the test. In example 1 is the example we started with. So a news report indicates that the mean amount of deductible that people with employer-provided health coverage pay in 2016 is higher than $1,077, which is the average amount paid in 2015. So here, the higher than is an inequality, and that reminds me that I should have told you that in this diagram, remember that equal sign always appears in the null hypothesis, either as the less than or equal to, or bigger than or equal to, or equal to, or equal to. So the equality sign always appears with the null hypothesis. All right. So given that, the fact that there is a claim saying that the amount of deductible pay in 2016 is higher than 1,077, there is no inequality in that statement. So what they're quoting here is the alternative hypothesis. And then, of course, the null hypothesis is the opposite of this. So it could be that in 2016, the deductible amount is the same as in 2015, or maybe even went down. So that's why we use in the less than or equal to. Now, remember, we use the alternative hypothesis to determine the direction of the test. So here we're looking for values larger than 1,077. So this is a right tail test or a right-sided test. And the inequality sign is pointing to the right. So we set a right tail test. And remember, if the statement gives you either the alternative or the null hypothesis, and then you deduct what is the opposite of the statement given to. Let's look at another example. So in here, a customer of a software company claims that their call center takes on average 15 minutes or more to resolve common issues. The software company has implemented a series of improvements and believes that the mean response time now is less than 15 minutes. So here are two things. The customer claims that the call center takes on average 15 minutes or more. So that statement is the null hypothesis because there is an equality here. Takes 15 minutes or more. So that customer is quoting the null hypothesis. And the company is saying, no, we implemented a improvement, now is less than 15 minutes. So they're giving us the statement of the alternative hypothesis. And again, we use the alternative hypothesis to establish the direction of the test. So now we're looking for values less than 15 minutes to validate the alternative hypothesis and reject the null hypothesis. So we're looking for values to the left of the value. So this is a left tail test or a left-sided test. And example 3, in this case, a research organization claims that the average lifespan, known as the replacement cycle length, of consumer desktop PCs in the United States in 2020 is 72.6 months. So it's not saying it's more than or it's less than, it's saying exactly that. So they're giving us the null hypothesis. So in this case, because this is equality, the null hypothesis is that the mean lifespan is 72.6 months. And so the alternative must be that is not 72.6 months. And that's what we write as an alternative hypothesis. Because there is nothing saying that they think is less than or that is more than. No, they're simply saying it is 72.6 months. And the only statement opposite to this null hypothesis is that the mean is not equal to that. So because this inequality, then we know this is a two-tailed or a two-sided test. All right, I will stop here with this recording. In the next part, we're going to continue with the error types.